So for our next discussion, we've assembled together a set of pioneers who essentially are the very early adopters of SDS technologies, and they're kind of here to talk about and discuss their experiences with us. And our moderator is John Mark Walker, who is the Gluster Community Manager.
Thank you. As you mentioned, my name is John Mark Walker. I'm the Gluster Community Lead for Red Hat. And as the least accomplished latecomer to this party of pioneers, I'll humbly serve as the moderator for the people who actually know what they're talking about. But I can say that most of us are actually, I guess, unnecessary for this discussion because we literally have someone here who wrote the book on software-defined storage. That would be Joe Arnold.
And I have a few copies.
Get it on Amazon now.
For free.
Yeah, I thought this was going to be the disruptive storage hooligans panel, but anyway, never mind. I'm the only one who looks like a hooligan, so. But it's been interesting. Speaking of hooligans, ever since Linux showed up in the data center and other open source technologies, it's been progressing towards a singular trend, and that trend has been towards agility. And as was noted in the previous panel, this agility and these trends in the data center towards open source and software-defined everything have been focused mostly on the compute side of the house. Whereas on the storage side, the old vanguards of the industry have been too content to sort of watch the compute technologies duke it out while they sat back and sold the same stuff they've always been selling. But now when you look at these trends towards agility, and customers love agility, it seems to win out in the long run. And now we're seeing that same trend apply to the storage industry as well. And so as we go through and introduce the rest of the panel here, I want them to answer the question to lead off, what role does the venerable proprietary SAN play in our current data center? And we'll start off with, I guess you, Kumar.
My name is Kumar Srikanti. I'm the founder, CEO of Blue Data. It's a stealth mode startup. Before that, I was a VP of R&D at VMware for storage and availability. I think the applicability of SAN in the data center right now is mostly traditional applications. I think the way they have scaled up, not scaled out, in the way that software-defined data center, software-defined storage is, or the other technologies are pushing. So if you take the traditional databases, they actually benefit by going up into the scale-up mode, and then they never did the scale-out models. So I think as long as those applications survive, they have some applicability in the data center. But as you guys can see, the whole devices and the change of the applications and the distributed nature of the data cannot sustain the SAN.
My name is Christos Kalantzis, and I've dealt with storage both at Netflix and Usendit. And currently at Netflix, I manage anything that has to do with persistence in the cloud, including databases and files and so on. I think it really depends on what your application is doing. At Usendit, we send large files. At Netflix, we stream movies. So we don't really need a SAN. We're not performing any POSIX operations while we're sending those movies out. So a SAN isn't necessary. Where SDS comes in, or object stores, is you've now got this REST API and you can serve these files, and for now that's pretty much all you can do, and that's all we need to do. But where a SAN is useful, or any POSIX compliant storage is useful, is when you're processing a file. So Netflix gets a master movie from a movie house. We have to encode it into different bit rates for different devices, and that cannot be done currently on SDS. So we're using systems. You're still using that, but you can scale that out in virtualized compute nodes.
Hi, my name is Joe Arnold, and I'm the CEO of SwiftStack. And what we do is we have a software-defined storage product, which is based on OpenStack Swift. And we have a controller which does the deployment, management, and the operations of OpenStack Swift environment. And what that gives you is something that looks and feels like what Amazon S3 provides, but you can run that in your own data center. And the model, so before I was working on this, I was at a company called Engine Yard, and we built a platform as a service on top of Amazon. And what we noticed was that there was S3, and then there was the ephemeral storage that was local to the running operating system, and then there was EBS, which is basically a block device. And there was no file system in that environment. And when we initially deployed customers in that environment, we were kind of freaked out. We were going, oh no, are they going to need this distributed file system? It turned out, nope. They use that POSIX file system to run their databases, to do any other transactional workloads, to do video editing, and transactional things. And then they stored all their data in S3. And then they could serve and store that stuff out via web protocols. And so that would be my answer to the where is it useful?
Well, we touched on a little bit about scale up versus scale out. And there seems to be sort of the assumption that if you're talking about scale up, you're talking about old proprietary SAN. If you talk about scale out, you're talking about the newfangled hotness of software-defined storage. Does that necessarily hold true? I mean, is that?
To a large extent it is. The biggest problem with the SAN is you have a one pipe going from a storage subsystem to a compute subsystem, right? So you actually can scale up the storage subsystem, but you still are limited by the pipes. So you want to enhance by adding more pipes. Then you start, when you enhance it by more pipes, then you have to figure out a way to coordinate on the back end. Then you start falling back into the, how do you coordinate the back end?
So John, I interpreted the question differently.
Okay.
So I think of like software-defined storage as more of like an umbrella term. And we're going to have a bunch of things come out that fall into
an umbrella
SDS.
Marketing term? Or
well, yeah, exactly, sure, that's fine. But it's going to be an umbrella term. We're going to have software-defined storage for this type of storage, software-defined storage for this other type of storage. And the reason why we're going to see that is because in the data center, what's happening is they're getting bigger. There's fewer of them because people are using more like software as a service type of applications. Data centers are getting bigger, and there's just no room for specialization, right? And so you're going to see that software-defined storage system for this workload emerge, and then another one for this workload emerge.
That sounds like a scary bifurcated world where we have a bunch of stuff that doesn't necessarily talk to each other very well.
It doesn't necessarily. Well, you look at the again, kind of the Amazon model. You have S3. The ephemeral storage, local storage, and EBS. And they each do their different things, and they're not necessarily replacements for one another.
Can I add something to
Please
that?
Please do.
I think to try to think of what Joe said is if you separate the protocol processing to the bit buckets at the bottom, then each protocol processing could be the specific to that application. There is a POSIX. And I think yesterday you and I were talking about, there are, I think you mentioned, I'll say what you said, is the Netflix stores everything on S3, but it brings back, and then all the applications are still talk POSIX. So then you actually convert them as a file. And there's other application that might talk object directly, in which case you would handle. I think that's what is it.
Absolutely. Actually, I want to go back to what you were saying about
The scale up.
scale out for databases. So it depends on the software. So traditional RDBMSs require POSIX access, even modern ones, but if you look at it at a higher level, you can scale out your database, assuming you've got a database that can do that. Netflix runs Apache Cassandra, and if you actually look at it from a very high level, I mean, what is Apache Cassandra? It's a software layer that's allowing you to read and write, but you can scale out. We run everything on AWS. We're running databases on AWS, not even on the high ones. I mean, we're using it more and more, but with limited IOPS and the right software, you can scale out even your data persistence layer on limited IOPS virtualized machines.
But that only works in certain workloads. When you talk about workloads, what is realistic now? If you look at someone in the data center now who needs a solution they want to deploy, where would you draw the line between what's possible and what's not possible?
It depends on the workload you're trying to achieve. Most libraries today, most tools today, still require POSIX access. So I'll give you a concrete example. Encoding movies. Encoding movies today, unfortunately, there's no software that'll do it off of an SDS. It requires the movie to be local. Those encoding libraries, want to perform POSIX API calls to the file, and you need it.
Okay.
But once it's done,
yeah.
you move it off, and then you just serve it.
Yeah, exactly. And so like in our use case, right? So we have a customer and they need to have a storage system that they can put 100 gigabit into it, right? And where do you go buy that? And if you try to build a storage system that has certain semantics to it, that say POSIX, and you have lots of people trying to write it at the same time, well, it's a difficult problem to solve. And so if you can relax some of the constraints on how you store the data, like a lot of the eventual consistent object storage models, well, then shoot, yeah, hey, we've been doing load balancing for years now with the web. We know how HTTP works. We just put a bunch of servers in there, bunch of load balancers, round robin DNS, and Bob's your uncle, and you can have this giant pipe to service a ton of devices all at the same time.
Ever since Amazon's S3 came out, we've seen a strong trend towards simplicity. And in this case, it's puts and gets over HTTP. S3 is one, Swift is certainly another. But it seems like POSIX isn't going away. I mean, it seems like as much as we'd like it to, it's still going to be around for a long time and remains that thing which shall not be named by many developers. But eventually, do you see like this going to a POSIX-free world, or is it always going to be sort of a mishmash of things that we don't necessarily want to happen?
Yeah, I think you had some comments yesterday. I want to make sure.
I think POSIX is not going away, at least in my mind. But I think it'll reduce. I think I can see that a lot of all the new generation applications, unless you are writing a financial application, you need a consistency models and the right synchronization on the back end. There are a lot of applications that do not need such kind of a consistency, So I do see if you want to draw a graph, I do see the overall market for POSIX or overall applications going down, and then the distributed, like an S3 models going up.
But it seems like there's a way to do all that stuff in a layer above, in the application layer. It seems like at some point, everything can move into the application layer, and the storage below it just becomes like sort of this simple
bucket.
Yes.
Yeah. Mm-hmm. Yeah. I mentioned that. I think the model that what VMware is trying to do and what others and even Gluster has is you want to have a bit bucket at the bottom, and I think even Ceph is doing that, and then you provide various protocols that process it. But you still need some kind of a consistency model at the bottom. Once you say POSIX at the top, then you put a significant amount of constraint at the bit bucket at the bottom.
Well, yeah, I mean, and I could also use the other argument, which is as you put more and more of this stuff in the application layer, you end up basically reinventing what POSIX was there in the first place, in which case, why bother? We already have POSIX, why reinvent it, right?
Sure. I mean, I guess we're all POSIX down at the very, very bottom.
Absolutely.
Because we have to write something down onto a spindle or an SSD, right? And so and just depending on how you model that out, our model is we represent a drive as a volume and write onto that. But, I think that putting the layer above that and exposing that in a way so that you can have these eventual consistent properties, and by not having POSIX constraint necessarily when you don't need it, can, I guess, liberate you to have much more flexibility on the type of hardware and storage system you set up.
And be able to serve files at a more accessible, using more accessible protocol.
Yeah, correct.
More accessible protocol meaning
HTTP.
Like HTTP. I mean, you look at all these devices, right? I mean, so I kind of go on this rant, and those guys probably heard it yesterday, where you have all these devices that are emerging, and an iPad doesn't speak POSIX to the cloud service it's running. It's speaking HTTP. And so if you have a storage system that can speak that exact protocol back to that device, then you can scale out your number of users a lot easier.
And yet, as we also touched on yesterday, within the device itself, it certainly speaks POSIX to the file layer contained within it. Although, much to my chagrin, you can't always access that layer very easily from the interface.
Correct.
But a lot of whether or not software-defined storage solution is viable, a lot of it depends on who you're talking to. And I think we all have experience sort of having that situation where the people we're talking to, the message resonates, like, yes, of course, I can absolutely see how applicable this is to what I'm doing. But also, as was touched on in the previous panel, the storage admin guy is traditionally opposed to any sort of innovation in the storage layer, because innovation to them means chaos, turmoil, data loss, which essentially means loss of their job. How do you address that sort of stability issue? And I guess this gets into the consistency issue. As you mentioned, object storage is eventually consistent, which in 90 some odd use cases is great. In some use cases, it's terrible. So how do you sort of address the sort of communication gap between different people within the data center?
So we have a very conservative model to how we do the storage. And then what we try to do is make the installation as simple as possible for them so that they know how to run and operate it. And so when we give them the tools to set this stuff up, we give them, it's not a binder, but here's your run book on how to deal with failures and what happens. And they can go through step by step and simulate all these different crazy scenarios that they can come up with and see how it tracks against any data loss or availability, and kind of get a chance to play with it firsthand. And because we're an open source model, they can go in and start looking under the hood, under the covers, and have some confidence to know that it's not just us as a vendor looking at it, but it's all the other companies and public clouds that are running the same software are, actually the code goes to those public cloud providers before it's going to get distributed to, our customers, which is kind of a neat advantage to have.
Christos, you may have a different take on that because you work internally at a large company. Do you see some of that same communication gap between different groups that you work with?
Netflix has this interesting culture where we don't see threats, we see opportunities. So quite frankly, if an administrator, a storage administrator came up to me and said, hey, I'm kind of worried for my job, and he doesn't see it the other way, then maybe he shouldn't be working at Netflix.
Fair point. Kumar?
Yeah, I have a different view on it, especially from VMware. By one measures, it takes less than 30 minutes to provision a VM. It takes apparently 3 days to provision storage, and it's a 3-way round trip. The system administrator goes to storage administrator and back to system administrator, back to storage administrator. So some of the projects that I worked on is actually, it's very funny. I was thinking I was the only guy who didn't know what is software-defined storage when I was coming here. Actually, there is probably multiple definitions. There is a isolation, bifurcation of protocols, bifurcation of control data path, and the administration and management.
Right.
The last one is a very important element of it. Essentially, it is co-owned by the hardware vendor. And so if you learn NetApp, you can learn EMC, or if you learn EMC, you can learn something else. So I think it's very important evolution in that space. I think they will learn, and they will, I think, welcome. I think it's a sea change. They will resist.
Sure.
But I think as the way the Linux really became a de facto standard was the developers and the dev teams went off and built it. So I think the Swift and the Amazon and others that I think doing it will have the profound impact on that, I think. That's
sure.
my optimistic view.
I just remember someone on our team wrote an article a couple of years ago all about sort of the new trends in storage and moving towards software and talking about the APIs and how you can develop applications using the APIs tied to different software storage backends. And one of the comments in that article was, "Holy crap! I'm going to lose my job." And it was a storage admin who had no idea. Wait, I have to learn how to code in Python now? What is this? But that's just one aspect of it. Coming from the GlusterFS standpoint, I can tell you that our message of agility and open source and software-based storage resonates a whole lot with the developers, more the webby type people, the people who are more likely to be in sort of like the DevOps crowd or to self-select into that group of, say AWS coders. But moving beyond that has been, I think, a whole lot slower. And it makes sense, why that would be, because that's just the way those people think, I guess.
Totally.
Not to criticize them, because there's valid reasons for that, because you can't just hop onto every new trend that comes along.
Yeah, we're seeing a maturation too, though, in just the people who work in IT, because I think as an industry, particularly with like web SaaS type applications, we're just maturing as an industry, and so not everyone's going to need to be a Python programmer or a hacker necessarily to run operations, or should have to have that level of skill to run operations in a data center. You know, it's not realistic to expect that to. If we're going to kind of grow as an industry, I don't think. So we have to have tools that make it easy to we still have a bar to hit in order to make this stuff operable. And you guys are working on that, we're working on that,
We're all working on that.
Yeah, we're all working on that, right? So.
One of the things, so we touched on scale up versus scale out, and how scale out implies software. But I would go further and say that scale out implies open source software. Where do you see like the sort of open source versus proprietary mix fitting in? Or which way is that trend going to be moving in the future? Kumar, you want to go?
I'll leave it to Joe. I'll wait for that.
I think there's a role for open source where that data is living, because you want to have the ability to store data on a storage system that you know there are a lot of eyes on the code, and you have a role in the direction that's going in. And particularly for the type of companies and projects that we're seeing, they have really, really big data centers. And you gotta believe that they want to contribute into solving their problems and not just rely on, you know, bunch of guys up in Silicon Valley to solve it for them necessarily. And so they need to have the core of that be open source because they want to impact its direction. However, they need to get, so where I think a commercial software can fit in is where they're concerned to time to solution or time to solve the problem, can accelerate that efforts, and then have a support structure in place for that open source project so that they have somebody to call, somebody to work with through an issue.
But do you see that many customers actually contributing, or are they mostly just want to use, they just want something that works?
The larger scale customers do contribute and get involved.
You probably have, yeah.
Netflix, who is huge in the open source community, and
exactly.
we're currently running our cloud prize. Please check it out. Plug, yes, shameless.
It's a cool bit of software.
It is, a lot of it is. So we do see contributions, and they do come from big companies. Spotify has contributed a lot of stuff at the Priam and SDI level, and you are going to get contributors. There's more leeches than there are contributors, but that's okay. There's nothing wrong with that, and I do believe open source will take over, and the model will be companies building, enterprise-facing versions or adding features to the open source. DataStax comes to mind with Apache Cassandra, where they provide support and they have added value as well, smaller proprietary added value, until the open source community catches up, and then they need to rejigger and add other added value.
It's such a dynamic environment. The way I've heard it described to us is that we're solving complexity, and that complexity is never going to really go away, and there's always going to be that next thing to kind of tackle.
I have a little bit different take. I think our previous panel said very clearly two things, right? One is the storage is the one place where we haven't seen the open source. Second is, as you can see, there's 4 GlusterFS, Ceph, Swift with OpenStack, and the Cassandra. These have definitely proven to be the very early adapters that starting to make a pretty big difference. I think from a customer standpoint, what I've seen, especially, of course, I worked at VMware, and what I'm talking to customers now in my current role, I think they are very open to the open source compared to 10 years ago. Very clearly, there is no question about it. But if you provide a solution that solves the problem, I think they are willing to take the proprietary or a closed software. But I do think the momentum around the open source is definitely very high.
I think while the movement has certainly been slower on the storage front,
Clearly.
I think that in the long run, agility wins, and I think the agility offered by open source solutions far outstrips the agility offered by proprietary solutions. I mean, that's sort of the model that we've been based on all along, and where we see things going. But of course, as Keynes also said, in the long run, we're all dead. So,
I think that somebody pointed in the previous one, the HDFS probably stores the maximum amount of data compared to all the traditional systems, and it's open source. So it's clearly Apache, a whole Hadoop world, and the cluster. These are all very good indications.
So let me play devil's advocate on that.
Oh,
but what are you storing on your HDFS? Are you just doing your reporting and your offline analytics, or are you putting your real-time OLTP stuff?
Probably not, right? Real-time stuff is not on the HDFS. But in terms of just the voluminous data, HDFS is the.
I agree. I was just playing
No, I agree with you. Remember earlier I said the traditional applications still drive the scale.
And eventually there's going to be a tipping point where the trust will be there. There's companies providing enterprise support for it. There already are, but there'll be more and more, and their reputations will grow. And then there'll be a tipping point where you will be seeing it on your OLTP.
I've seen some graphs that plot scale up versus scale out performance. I think performance measured in IOPS, and it kind of looks like a staggered stair step where you scale up, wins out for a while, and then you get up to a certain point, and your scaling out is more performant than. I guess the question is, looking at the economic models that go into deciding how to deploy storage solutions. How large do you have to be in order for a scale-up model to make sense? Can you derive benefits from software-defined storage at smaller levels, or do you have to really have a large scale-up model for it to be successful?
I think you can be successful at any size company using scale-out. Especially for smaller companies. Scaling out is usually a lot cheaper than scaling up, so a lot of startups will start with they'll prototype and scale up until a certain point, but then eventually they hit a wall, and it is cheaper to scale out at that point.
Well, that's been the promise, but what I've actually seen in practice is that the promise of commodity hardware and scaling out, but what ends up happening is that they have to buy the expensive networking gear, the expensive switches and stuff that makes the scale-up model actually work well in terms of throughput. And at the end of when you add it all up, I'm not really sure it's that much cheaper now.
So really small companies and really big companies, it's cheap. You're right. The intermediate sized companies do have to make a decision at that point.
I think there is an answer in your question itself, is you said the stair models. So flash versus the traditional hard disk, you can buy, your IOPS is extremely cheap and your capacity is expensive with flash.
Sure.
And then it's vice versa with the disk, right? Disk IOPS is very expensive, the capacity is very cheap. So if your scale out model is like you wanted to build, let's say 4 servers, then your question is whether your networking gear is going to cost more than your flash gear in a single system, right? That may be one of the underlying. So I do agree that depending on the application, that you can actually scale out models does provide you for VDI is a very interesting use case of the scale out model where we are all trying to build things for the VDI, and that's one case where I can see the opportunity even in a very small installation. Okay.
You were one to jump in there.
Across the board, it's going to be economical to do software-defined storage because you're taking that software and you're extracting that out from that hardware, and you're just going to get the most flexibility from it. So if you're not having to go to that box necessarily to configure it. You're remotely configuring that box so that it can do what you want it to do from a software-defined storage perspective. And you want to grow from there, well, then you can grow. But no matter what, that first box is always going to be based on some commodity platform. And your network is going to be what it is going to be, right? And you have to do the math and figure out how many IOPS and how much network throughput you need. And but either way, you still have to buy that infrastructure anyway.
And speaking of IOPS and network throughput, well, we're coming up to the end. But one last question before we disperse. When you look at public cloud infrastructure, and especially with storage, you're talking about latency issues and how it can really impact performance. How do you guys handle the sort of public versus private, I guess, debate? And I want to start with you, Christos, because in Netflix, you say you do everything in AWS. I'm curious.
We do everything in AWS, correct.
And that you don't suffer from latency problems when you're talking?
We design our applications really, really well.
So if you're...
No, but we do. I mean, we have a software service architecture, and, you know, sometimes certain applications need to go through a lot of layers, and you do suffer a little bit, but you also got to look at the flexibility and what you're getting out of it.
So agility wins.
Yes.
Any naysayers?
So I
on that
think
point?
I want to make sure I understand your question is, are you talking about WAN latencies, or are you talking about EC2 to S3 latency? If it is WAN latency, there's no question public storage cannot fit into the application patterns we
Sure.
need, unless you are reading a Netflix movie that is preloaded. Right? And so, but if you're talking about within the data center, versus in S3 versus EC2, I think he pointed there is some additional noisy neighbor problems.
Noisy neighbors, yes, always the problem. Unfortunately, we have to leave it there because the red light is on, and I think I'm about to get the hook. So, thank you.
Thank you.